ground with his hands raised. Don't shoot me. There's this.
Let's start.
And they shot him anyway. They shot him anyway. He's on the ground with his hands up and they shot him. It's just crazy. The ink.
All right, let's get started. So you're working on PS10. It's due Monday. I got ahead of myself today and released PS11, so you can look at that. Remember, the first thing you have to do is by Wednesday, you have to go to a website and tell us what your team is made of, either just yourself or you and someone else. Any questions or problems on anything? Yeah.
Should we start over? All right, good to go.
Okay, we'll continue.
I'll edit it out.
Okay, so if there are no other questions, oh, we got one, yeah?
Yeah, I noticed that there's an assignment called EC11, I think it's extra credit, and in the rubric, there are total points are 304.
Okay, so
there's a maximum of 50, right?
yeah, so if you look at the assignment EC11, that's extra credit. You do it as part of PS11 if you want to. You're limited to 50 points of extra credit. The rubric has like over 300. It's just, you'll be implementing an asteroids game for PS11, and if you go above and beyond what's required at a minimum, you get extra credit, but not 300 points worth, just 50 points worth. Let me get this fixed. Go ahead and ask your question.
With the other version of PS10, if we just download from the CPM, is that the most updated versions of the PS10? Sorry.
Yeah, hold on a second. Okay, so I sent out a couple of notices on Piazza about modifications to PS10, but it's been a couple days now. Yeah, the latest version is what you get with the CPM. Okay, first thing I want to do today is talk a little bit about the file system part of PS9 that you did, and then we'll talk some more about polymorphism. So as you recall, you had to implement 3 methods, and this was the first of them, depth. So the depth of a file system, it says if the parameter is a file, i.e. a document, the depth is 1. If it's a folder, then it's one more, the depth is 1 more than the depth of the deepest thing that's contained in the folder. And I just pasted here sort of the skeleton of code that you see is common to all these methods. So we got the base case, which returns 1 as it's supposed to. And then in the recursive case, we got to look at what's contained in the folder and take appropriate action. And inside this loop, we're going to make a recursive call to depth. Now we've got to do something with the result, but I just put it there to remind us we've got to do something with depth. So we're writing a for loop. What kind of loop is it? Accumulation, optimization, searching. Yeah? Optimization. Okay, optimization, because you're looking for the deepest thing. So that means we're going to need a variable up here. We call it something like max depth so far. And we'll call it 0 because we haven't seen anything so far. Then, since this is an optimization loop, when we're done, well, before we're done, we need to do something. We need to update each time through this loop right here. We need to update max depth so far. So how do we do that? How do we update? So max depth so far is going to be the depth of the thing in the folder that has the largest depth. Yeah.
Maybe just do like max depth so far plus plus.
Well, so the suggestion was adding 1 to max depth so far. Well, you got to add 1 at some point. What I'm going to do is when I'm done, I'm going to do that. So I'm going to take the deepest thing that I found in the folder and then add 1 for the folder. That's what it says in the comment. It's 1 more than the deepest thing that we find. So in here, I don't want to necessarily add 1 to max depth so far. What do I want to do? How do I want to change max depth so far? Yeah?
So for each loop, you want to create a condition that compares depth F to the optimization.
Okay. So what he said was have a conditional that compares max depth so far to the depth of F. And, you know, sort of if this is bigger than that, or the other way around. If that's less than depth of F, we update max depth so far. But it's, as you know, I don't like to write a conditional in a method call will do, so we'll do it this way. Okay. So I just, each time through the loop, I update max depth so far by replacing it with the larger of max depth so far and the depth of the current F. So when the loop ends, I know the depth of the deepest thing. And then I return 1 more than that to account for the folder itself. So there's that solution. It just takes a little bit of code in the right places. And the key is understanding what kind of loop you're writing. Any questions about that? Anyone have a different idea how to do it? Are you hearing me okay in the back? Sort of?
You could turn it up.
I'll go turn it up a little bit. Okay, that sounds. I can hear myself walking, but you can't hear my voice.
Where's the microphone then?
Right here.
It's pointing down, but if you point it up, then it hits your neck. It makes a noise.
Okay. I'll just talk loud. Okay, what about this next one here? I want to count the folders in the file system.
There's a hum now.
Okay. Just go over and turn it down slightly. One of you. Okay? So we got to count the number of folders. Clearly, if we got a document, the answer is 0. No folders here. Otherwise, what do we have to do? What kind of loop do we have to write? Okay, so the accumulation loop. We got to add up all the folders that are contained in each thing that's in F. So we need an accumulation variable. And in here I just say, and so each time through the loop I add to count the number of folders contained in F. And then what do I return as a result?
Count plus 1.
Okay, is it count or count plus 1? Yeah, it's count plus 1. Let's reflect for a second. What would happen if I just said return count? Would I be off by 1? Okay, let's see. So up here, I'm just returning, instead of saying count plus 1, I'm saying count. So So up here it says count folders, the answer should be 12. So let's run it and see what it says. It says 0. It's not off by 1, it's off by everything. So why is that? That's what I expected. Maybe not what you expected. Why is it not off by 1? Why is it off? Why is it, yeah?
Because it just returns what it was initially like assigned to.
No, it's going through the loop. It's calling count folders and adding it into count. Still doing that, yeah.
Because an off by 1 error is compounded over multiple errors.
Okay, the off by 1 error is happening at every level. Because we don't say count plus 1, count folders always return 0. The only place we count a folder, this is where the folder itself is counted. And if the folder itself is never counted, the answer is always going to be 0. Yeah?
Could you also just initialize count to 1 for the current folder?
Sure. So the other thing that I could have initialized count to 1 and just returned count. But if the point being, you know, a mistake like this in a recursive method is going to happen at every level of recursion. And so it turns out that without that plus 1, you're hosed. Yeah?
So, I got a few questions. For one, I looked at how it would, why it would be a good idea to either return count plus 1 or initialize count equaling 1. Because what if there are no folders?
Okay. So in this scenario, if there are no folders, we set count to 0 and end up returning 1, which is the right thing.
But I'm saying there is one folder.
Oh, there is one, yeah, because we're looking at it. We got a parameter here, FD. And it wasn't a document, so it must be a folder. So we need to at least return 1.
Okay, so where does it get? So it includes not itself as well as the folders inside
Sure.
itself?
I want all the folders, and that includes the top level folder.
Okay. Oh, yeah, that's kind of unexpected. And so my other question is, where is this folder you're getting?
Well,
I can't figure out how it's defined or how it works on all the computers.
Well, if you look over here, it's kind of small, but there's the file system demo that I gave you. It's just sitting in my project. And when I,
Oh, here it is.
up here in main, I get this will give me the folder for the project, and I just put demo on the end. Okay, now what about search by name? We return true if we find a file or a folder with a specified name. So if it's a document, we just compare and return true or false, depending on whether the name of the thing is equal to the name we're searching for. Otherwise, we need to write a searching loop, right? So what do we do? Searching loop just involves a change here and a change inside the loop. So what do we do inside the loop? Yeah?
Check if the file name equals the name provided. And if it's the same, return true, otherwise do nothing.
Okay, so I guess you say check if the file name has the name. So we're recursively going to find out whether F contains anywhere in it a folder or a document with that name. So the question is, what do you do if it returns true? What do you do if it returns false? So what do you do if it returns true?
Return true.
Yeah. If it turns out that the recursive call found a file with the correct name, then we're going to return true. Now suppose we get to here and we did not find, we're only going to get to this point if we did not find a file or a folder contained in FD that has the right name. So what do we do?
Return false.
Just return false because we didn't find it? Okay? So we're going to make the same mistake that we made before. Let me run this. And we find out that, no, it did say true. I stand corrected. because of files. But there's a problem. False isn't the right thing to return in all cases. So what if you have a folder called foo, and you're searching for a file or folder named foo, and that folder is your top-level folder?
Isn't that your base case?
The base case isn't an empty folder, or a folder. The base case is a file. Yeah?
Don't you just need to copy that line inside that if statement and put it at the beginning of the else? Right after it?
Yeah, we could do it that way, or we could do it this way. Right. The loop is just checking for things that FD contains. We also got to check FD's name. Yeah?
Probably not by much, but wouldn't it technically be faster to check that before?
Yeah.
Yes.
That's your base case.
It would be faster because, you know, rather than do all this recursion and then find out the folder itself had the name, it'd be faster to do the check first. In fact, what you can see is we can change this up this way. So we'll start just by checking if the file or folder has the right name, and then else return true if it does, and then else if we're dealing with a folder, we do this, and at the end we return false. That's another way to. So that's sort of, it doesn't have the same structure as our other solutions. Yeah?
Why do you need the else if? Can you just put else and then it'll just say it'll check anything that's in that folder for that?
Yeah, well, we don't know it's a folder. I put else here because I'm not sure what happens if you call list files on a document, which we would be.
Yeah. Okay.
If we were past a document, if FD is a document. It may be okay, I didn't know for sure. So anyway, that's just another way to spin it. Let's see if we get any different answer this time. Oops. There's a compilation problem. Oh.
I think it's on 185.
Yeah. The problem was there wasn't anything being returned if the else if was false. So I just need to move the return false out of the else if. Okay, so I mean these file system things are relatively easy if you understand the structure of the recursion, and practically impossible if you don't. And you probably found that out on the assignment. Any last questions? Yeah.
Just really quick. If FD is a document, wouldn't FD.list files return null? And then that would just skip that part?
Yeah, I'm not sure.
Okay.
We can try.
Okay. I'm just should actually go test mine on the document.
Yeah, so it works that way too. Yes, Ruby?
So if this is a search function, then where's the searching being done? Like, until we're not entering in a file name or anything.
No, there's a parameter right here.
Yeah, but, and I can't find any file names FD.
Let me talk to this after class.
I'll probably be able to follow as we go along.
Yeah. But any other questions? Okay, we're going to move on to something different. I want to write a paint program. And here's how I want it to work. So this is the final product I want to get. So I got a painting surface. I can pick a shape like rectangle and a color like green. And then I use my mouse and drag it, and it'll draw the rectangle, or I might switch to a red oval, and I can do that, or I might have a blue line, and I can do that. So that's all I want to get. So very simple paint program. And of course you can have multiple lines and rectangles and so on. And I'm doing this just to illustrate, I'm continuing on my quest to illustrate the power of polymorphism. Now, I'd like to be able to just write this all from scratch in front of you, but that's, I can't do that. So what I've done is I have 7 waypoints. So I've got paint 1 through paint 7. And we're going to start with paint 1, and we'll see how we'll make it work after a fashion. And then we will add some stuff to get to paint 2 and add some stuff to get to paint 3. So we'll just move through the example that way. So I've also got a jar file to show you what paint each of these things is supposed to behave like when I'm done. So here's paint 1. And you can see that it just draws a blue oval. If you change your mind about what you want, like a green rectangle, if you iconify it, well, that's unfortunate, and bring it back, well, it's still blue. Well, okay, I've forgotten what this thing does. So anyway, all paint 1 wants to do is draw a blue oval. So
Really?
let's make it do that.
Mine works just fine.
Okay, so there's paint panel. Let me run. I'm going to run the code as it exists right now. And that can't be right. Oh, I opened up the wrong thing. That's the final version of paint. I want paint 1 here. Oh well. I even looked at it before class. Let's look at the paint panel here. Let's see what's involved, and we'll see what I really had in mind to add to it. So you can see that we have a constructor, and it takes as its parameter 2 button groups. Now, I haven't talked about button groups before. What do you suppose a button group is? As a reminder, I'll run the program. All right, always launch without answers. Okay? So the paint panel is the white area right here. Paint is the top level J-frame. We're not going to worry about it. We're going to look at the paint panel. And so when a paint panel is being created by the J-frame, it receives as a parameter 2 button group objects. Anybody want to guess what a button group is? Yeah?
My best guess is it's a J panel with a collection of buttons in it.
He said a J panel with a collection of buttons in it. Reasonable guess. It's not a J panel. Basically, it's a collection of buttons, of radio buttons. Yeah?
It gives you like a choice between several options, and you can only choose one.
Yeah. So these things are called radio buttons up here. And you notice when I click rectangle, oval is unselected and line. And then red, green, and blue work the same way. So if you just threw radio buttons up there at the top, they'd all be independent. You could click them in any combination. If you put them into groups, only one at a time can be selected. And then the button group object has a method that'll tell you which one is selected currently. So that's what I get as a parameter here. So what I'm doing is I'm shaving the shape button group and the color button group as instance variables up here. That's all the constructor's doing, other than setting the background to white. Okay, and then I'm changing the paint component method. I'm overriding the paint component method. This, I'm calling the overridden method in the original class, in the JPanel class, just to get the background right. In the constructor, I set the background color to white, and so that call paints the thing white for me. Then I do this, I turn on anti-aliasing, which I mentioned last time, just makes the graphics better, but a little bit slower. And then I've written code here which just picks a random color. So we pick a random color based on what it is, but use a random number generator, and we either set the graphics to use red, blue, or green. So I'm ignoring the button groups. Now, I've had you read about switches before, but I believe this is the first time I've shown you a switch. So let's pause here. It has nothing to do with polymorphism, and talk about switches. Who could summarize how a switch works? Yeah? Okay, so he said kind of like an if-else statement, so it fills that niche. Okay? So you said it's more specific. So basically what happens is this is evaluated, and that's either going to be 0, 1, or 2, because that's what NextInt does. And then the switch just comes and sees, okay, that thing I just evaluated, was it a 0? Was it a 1? Was it a 2? And whichever one it was, it executes the code, all the code, after the colon. So if it's a 0, it'll execute that, it'll set the color to red, and then it will break, which ends the switch. If you leave that off, it just goes on and sets the color to blue. So typically, you want to break at the end of each case. Yeah?
So like, why are cases represented as numbers again?
Why are what?
Why are the cases represented as numbers?
Okay, the cases are numbers because this is a number.
Oh.
Okay? If this is a string, the cases would be strings.
And can they be strings?
Yeah. Yeah, they can be strings. Yeah?
What will it do if that evaluates to something that isn't in the case? Will it
Okay.
skip it?
So it can't, but suppose it's evaluated to 3. NextInt's guaranteed to give you back numbers 0, 1, or 2. But if for some reason it evaluated to something else, none of the cases would be matched and the switch would have no effect. Now you can, though, at the end, you can put default. And that will, I don't like the way that's indented. And then if it doesn't match any of the cases above, it'll do what's at the default. But we don't have any need for a default here. It has to be one of those 3 things. So anyway, we're randomly setting a color, and then we're randomly drawing a shape. So that's what that thing does. Okay, I guess I didn't have anything I wanted to change about this. This is just to show you how it works. Now, since every time paint component is called, we're getting a shape, a random shape drawn in a given color. When I run this thing, how could I make the shape change? When is paint component called? Yeah.
Is it called whenever you put buttons?
Called whenever what?
You put all the buttons?
No, paint component's not. Paint component is called automatically by swing. Swing is this set of classes we're using. Okay? When would swing need to paint a component? Right now it painted it and it's not doing anything now. What do you think would force it to repaint? Yeah?
Mouse click?
No, not a mouse click.
Rerunning it?
Well, rerunning it would force it to be run. So there we got a blue circle. I'll run it again. We get a red circle, a red oval. I'll run it again. Right? So every time paint component's called, we're getting something random. But watch this. I'm gonna drag the mouse and increase the size of the window. Why is that happening?
It has to repaint every time you're.
Yeah, every time when the window gets bigger, swing notices, oh, it's bigger, I need to repaint it. And we've got sort of a random paint component method. So when swing needs to redisplay something, it calls the paint component method. And ours is flipping a coin to see what to draw. That's why before I tried to iconify it and bring it back, and nothing, I guess I got unlucky. Because this time it comes back different. When I first tried it, I got confused because it came back the same, and all of a sudden I lost my confidence, but I understand what's going on now. You know, so that happens, or we could take this window here and move it on top, and well, it looks like it's not having to redisplay there. Sometimes you can get it to redisplay by obscuring it and then unobscuring it, but it's obviously it's not doing it there.
Or what if you try clicking on it now? You know, like clicking and unclicking it.
No, clicking on it doesn't cause anything to happen.
How about shrink and bring it back up?
Yeah, I did that. I shrunk it and brought it back up. That did it. Or I can do this and it starts to change. Okay, so I'm just illustrating you the power of overriding the paint component method, because that just controls what you see. Okay, So let's see what, that was paint 1. No, actually I'll leave that up. Now let's look at what paint 2 is supposed to do. So I'm running the jar file for paint 2. And now it's not random anymore. The way it works is if I pick blue rectangle and then iconify it and bring it back up, now I have a blue rectangle. Or if I start resizing it, it stays the same, but if I change the settings, then it changes. So it's paying attention to those radio buttons up there, but it only pays attention to them when redraw needs to happen, when paint component is called. So what will we have to change about paint 1 here? Let's go to the paint component method. What will we have to change to make it behave like I just showed you? So that whenever it needs to paint the component, it pays attention to those buttons. Yeah? Okay? So we're not going to pick a color at random. How will we pick the color? Yeah? We'll have to look at the button groups to decide which color to pick. Okay? So I'm not going to make the change here. I'm going to go to paint 2 and make the change there. So paint panel's the same, paint component looks the same, and here's where we've got to set the chosen color and draw the chosen shape. So let's start with the shape. It says here switch, and it looks at shape buttons.getSelection.getAction command. And based on what getAction command returns, we have to have our switch do something. Who knows what getAction command does? Obviously, shape buttons.getSelection will return the selected radio button in that button group. Anyone tell us what getAction command does? Yeah?
It like finds the ID of the...
He says finds the ID, not quite. Let me show you up here where we create the radio button. So here we add to the shape panel a radio button, well, an oval, the button for oval, the button for rectangle, and for line. But look what we do right here. So when I create the radio buttons, I set an action command for each one: oval, rect, and line.
So getAction command.
So getAction command gets that string. So if it was the oval button that was clicked and we do getAction command on it, we'll get back oval. So it's another way of telling which button was clicked. Yeah?
Is that the same thing as like giving it an ID service?
Yeah, you could give it an ID, there are various ways to do it. I'm just illustrating a different one here. Okay, so we need a switch. We got a switch. So what would be the first case? Okay, it's going to be oval. And what should we do if we get oval as a parameter? We need to draw an oval, right? So I got to go back here and get the code to draw an oval. In fact, I'm just going to copy all this. Make my life a little bit easier. But now, here we're not looking for 0, we're looking for oval. And we're not looking for 1, we're looking for rect. And we're not looking for 2, we're looking for line. And what if it is none of the above? What will happen? Can't be none of the above, but suppose it were. Nothing will be drawn. Now, we've also got to set the color right. So let's go back and copy that code. The switch will be like this. Except it'll be color buttons. And what are we looking for here? What are our cases going to be? I mean, to know for sure, you need to go back and look. Okay, we called them red, green, and blue. Okay, lowercase. That's important to know. So, red, green, and blue. And just for the heck of it, what should we do if we get something that is neither red, green, or blue? I'm going to say we'll use black just as a default. And again, that's not going to happen with our existing buttons. Yeah?
Why are you calling blue?
Why am I saying, why am I doing
Green
that?
equals blue, blue equals green.
Good question. Okay, so now this should work like that jar file did. So if I cause paint component to be called, it's still stubbornly drawing that color, but if I do blue rectangle, then it switches. Okay? So, so far, what polymorphism are we using here? Where are we exploiting polymorphism? Yeah. Okay, well, yeah, back in the paint class, there's lots of places where we're taking components and adding the J panels, and that's because of subtyping. What about in this method right here, paint component? Staring you right in the face. What are we doing in the way of these polymorphic ideas we've been talking about? Yeah?
Overwriting a method that we inherited from the
Right.
class.
We're overriding a method that we inherited from JPanel. So by default, all JPanel would do is draw a blank region. We've overridden what it does. And I mentioned this before, I'll mention it again. This is a really powerful idea because the swing library, all these classes that make GUIs possible, were written years and years ago. And they're designed, they can detect when a JPanel needs to be painted again, and it calls paint component. And we got all that power at our disposal simply by overriding paint component. It's already being called, we just got to make it do what we want it to do. Right? And if we misspell this, I showed you this last time, but it's worth repeating. What's going to happen when we run the program? So we're no longer overriding paint component. What's going to happen? Yeah? Right, it's just going to be a white panel. There it is. Now, what if we do this? Let's go back to here. Let's call it the right name. Suppose we do this. Okay? Let's run the program and see what happens. Okay, so it said painting, because paint component was called. And you'll notice, as I resize it, you know, it was called not an infinite number of times, it was called at a few discrete times. So that's just that's just swing at work, deciding when it's time to repaint something. Okay, so what will be the logical next thing to try to do with our program? Because right now, we can pick, but we can't see the results of our picking until we resize. So what would be next? Yeah?
Cause it to repaint when you actually click on one of the radio buttons.
Yeah, right. We would like it to repaint, you know, when I go and well, We could make it so when I change to rectangle, it draws a blue rectangle. Then I change to red, it draws a red rectangle. But rather than do that, what I'm going to do is, I want it that you pick your color and your shape, and then you click, and that places the shape where you want it. That would be the next thing, is actually be able to place shapes. Okay? Yeah?
So where in the current program does it actually like change shape if like the window is resized?
Right here, paint component. Every time the window is resized, paint component is called, and at that point it looks at the menus and picks a color and a shape and draws it. And if the color and the shape have changed since the last paint component was called, then it'll change before your eyes. So let's see here. So we're going to paint 3. So I'll run paint3.jar. And we got it red rectangle, and I click, and it comes up like that. So I click, and that centers the rectangle right there. If I do green oval and click, it draws a circle. And if I say blue line and click, it draws a line. But it's using the mouse coordinates to decide where to draw it. Yeah?
So if you click blue line somewhere else, will it draw another blue line?
Yeah. So wherever I click, it just lays it down. So if I switch back to blue rectangle and click, I'm determining the center by what I click on. Yeah?
And it won't change any of that if you move the...
Right. So if I move it, it's just
Okay.
redisplaying what was there before. It's still, paint component is still being called over and over again. But in our old version, paint component would either flip a coin or look at the buttons and paint something new. In this new version, that decision is being made outside of paint component. So obviously there's a big change that we need to do in going from paint 2 to paint 3. And what will that change involve? How are we going to find out when the button's being clicked? That's when things happen, is when you click the mouse.
Mouse listener.
Right, there's going to be a mouse listener that detects a click. And it will decide, okay, so what will happen when it's clicked? What will have to happen? Okay, you have to get the coordinates of the mouse to decide where to put the thing that's being drawn. Then what? Yeah.
Take those components, put them into the actual draw method, draw the shape.
Okay, so you'll have to, what you have to, so you don't, what you'll find out is we don't draw the shape right away. What we're going to do is save the shape to a data structure, to a list of shapes that need to be drawn. Then every time paint component is called, it will go through that list and draw each one. So we'll do that. First, let's take a break, and then we'll move to paint 3. All right, let's get started again. I've concluded that this thing only works if it's like a millimeter from my lips. It's fine, it'll pick up my collar hitting it, but it really is not amplifying my voice, so I'm just going to talk loud. All right, so we're working now in Paint 3, so I brought that up. And you'll notice right away that I've added 3 new instance variables. So what are they for? So they're lists of ovals, rectangles, and lines. Why do we need these 3 lists? Yeah? Okay, so whenever paint component is called, it's going to draw everything in the ovals list, everything in the rects list, and everything in the lines list. So when the mouse is clicked, we will add something to the appropriate list. And then when something is, paint component is called, it'll iterate through the list and draw everything. Yeah?
Doesn't that cause a layering issue? Like say, like if it always draws the ovals and then the rectangles, like say you draw an oval and a rectangle on top of it, then...
Okay. So he points out something important but subtle. If I, suppose I draw the oval first, draw a line on top of it. So you'd expect the line to cover little points on the oval. But then if paint component draws all the ovals, draws all the lines, let's say, before it draws any ovals, that effect would be lost. And so that's a problem that we'll have in this version, but we'll fix it. That's something we'll fix going to the next version. It's also kind of a pain to have 3 lists. It'd be nice to have 1. Now, what is an oval? What class is that? Have we seen an oval class before? Let's look and see. It says paint3.oval. So that's a class I wrote. So I had to create classes to represent ovals, rectangles, and lines. What information do you think we have to store in an oval object, let's say? If you cut open an oval object, what information will we need to have in it in order to be able to draw it? Yeah?
Probably a center point and 2 radii.
So a center point, so the XY center, and the 2 radii, he said, so a radius in the horizontal direction, a radius in the vertical direction, yeah?
Color.
And a color. And we have similar information about rectangles and lines, but it's different for them all. So let's go to the bottom here. And so there's oval. So I created an oval class, and it has center X, center Y, so the center coordinates, the 2 radii, and the color. So when you create an oval, you give it the XY of the center and the color, and it just hard codes 100, 100. That's something else we need to fix. So we only create things with the radius of 100 right now. Now, here's a method. It takes a graphics G and draws the oval on it. How will that method be used? Where would that method be called from, that paint method? Yeah?
From the loop that you're painting everything on out of the lists?
Yeah. You go look in paint component, we'll have to put a loop. That'll loop over all the ovals and call paint on each of them. Then there's rectangle with center X, center Y, a color, a width, and a height. With a constructor that always creates a rectangle of the same dimensions. And paint, which knows how to paint rectangles. And finally line, it has a start X, a start Y, an end X, and end Y, and a color. So that's a bit different. And again, a constructor and a paint method. So I wrote all those classes so I could store the information, because we got to store the information somewhere so we can redraw every time we need to. So let's go do that. Back up here. Let's look at that method. That's a helper method I wrote. What does GetColor do? If you call GetColor, what does it return? Yeah? Right. So what he said was it looks at the color button that's selected, and returns a color field. So if the red button is selected, it returns the color red, not the string red, but the color red. So it's, you've seen that code before. It's just in a method now. This is what's called when the mouse is pressed. Okay? When the mouse is pressed, it looks at what shape has been requested, either an oval, a rectangle, or a line, and saves it away. So, what do we need to do right here? We got to create an oval and save it. Yeah?
GetColor doesn't have a return type, but it returns something.
GetColor?
Why and how does that work? Yeah.
Right,
Oh,
right.
I return color.
Yeah. Okay, so what do we need to do here? We're supposed to create an oval and save it in that ovals list. So how do we do that? Yeah? Okay, so we need to get the coordinates of the mouse and use that to create the oval object. And then with the oval object we put in the ovals list. So we could do it in one line like this. So I'm going to add to ovals, a new oval, and we're supposed to pass in X, Y, Z, X, Y, and color. Okay, so how do we get the X coordinate, how do we get the X and Y coordinates where we want to place the oval? The center. Yeah?
You do E.getX.
Right. E.getX will tell you the X coordinate of the mouse at this point in time. Or the mouse coordinates when the event happened. E.getY, and then what color do we want to use? Yeah?
Whatever button is pressed.
Whatever button is pressed, and how are we going to... Right, remember I have that method down there, GetColor. Okay, so that's the deal. Yeah?
Why did we use E dot to use the get Y method?
E is right there, it's the parameter. When you click the mouse, and a mouse pressed action happens and we're listening to it, we get as a parameter an object that has information about that event. And we're interested in the X and Y coordinates right now. Yeah?
So would this create an oval that fills up everything from 0, 0 to where it crosses now?
Say that again.
Would that create an oval filling up everything from 0 to 0 to where the mouse is now?
No, what it will do is it'll create an oval that's centered at where the mouse is now. But I hard-coded the dimensions into it. So we're not yet to the point of letting the user pick the size of the oval. Okay, what about rectangle here? What do we have to do? It's pretty much the same, right? And line is okay. So when the mouse is pressed, we create the requested kind of object and add it in. So all that's left is to, up here in paint component, is to do the painting. So what's it going to take to paint all of the ovals?
For each loop.
Right, we just say for each. So for each oval that's stored in the list, what do we do with each oval? Well, what can you do with an oval? You can paint it. And we got to pass it this graphics context G. So we send it there. And that will paint all the ovals. We paint all the rectangles. and we paint all the lines.
You guys finish, change that.
Now, if you find yourself writing similar code over and over like I just did, you should think to yourself, maybe there's an easier way. It'd certainly be easier if there were only one list, but my problem is ovals and rectangles and lines are different types of things, and I can't put them together in the same list. So that's what we're going to change when we move to the next level. All right, so this should work now, unless I've forgotten something. So let's try it out. Well, gotta make sure I'm running the right thing. All right, so red oval, I place. Red line. Green rectangle, another one, another one, another one, another one, another one. Okay, so that's working just fine. But let me ask you this. When I click the mouse, what else is happening? What makes that thing appear? So if I say, give me a blue oval, and I click, yeah, I know I just created a blue oval and stored it in that list. But what made paint component be called? Because if paint component isn't being called, we wouldn't see it. Yeah.
Mouse click.
The mouse click doesn't cause paint component to be called.
You're calling it paint.
Let's look at the code and see. So down here is the mouse listener. I think I know what you were saying now. I misinterpreted it. So when the mouse is pressed, there's that repaint method. So repaint says, what repaint does is it tells Swing that you would like this component to be repainted. So we don't call paint component directly. That's Swing's business. We just say repaint, and it takes care of doing everything it needs to do in order to call paint component. So what would happen if we did not request that Swing repaint? So red oval, green rectangle, blue line. Where are they?
Not painted yet. It's not painted.
Yeah?
Being stored in their lists and never mentioned.
Stored in their lists, but paint component wasn't called. So they haven't been rendered. But if I just resize this slightly and force paint component to be called, there they are. Okay? That's why we need to ask Swing to do a repaint right there. Yeah?
Do they need to be stored in a list to get printed?
Yes, do they need to be stored in a list to be printed? Well, they need to be accessible to the paint component method. And the way the paint component method works here is, yeah, they need to be in the list. So like if I comment this out, what's that going to change about my program?
It's not going to paint all the rectangles.
It'll never display a rectangle. It'll create them. So I can put ovals here, but rectangles will never show up. They're being created and stored. They're just not being painted. So we'll put that back. Okay? All right. Let's think about this. I mentioned what I don't like about this is I've got 3 lists. I'd like there just to be one. So think about how we could change this program. So here are the 3 lists. I'd like just to have an array list of shape. Okay? I'd like to be able to say private array list of capital S shape and put all of these objects into that list. But that won't work because they're all different types. How could we make it so that ovals, rectangles, and lines could be stored in an array list that contains shape objects? Let me get you back there.
You could make a class that's called shape and then have oval, rectangle, and line.
Okay, so one idea is to make a shape class and have those other 3 classes inherit from it, extend it. What's another option?
Use an interface.
You can use an interface. Now we're actually going to explore both. I'm going to start with the interface, because that's a little simpler to see. So this next change we make in going to Paint 4 is not going to change the behavior of the program. It'll look the same, except what you pointed out earlier, the overlapping will be done correctly. Yeah?
Can you also just do an array list of objects?
Okay, he said, you can create an array list of objects, because anything can be stored in a list like that, as long as it's an object.
And then like automatically knows.
Nothing would be automatic. You would have to do typecasting. You'd have to figure out what. Let me explain that later. Let's go to Paint 4. There's the top level. Here's the panel. And you see what I did here? I declared an array list of shape objects called shapes. Got a question?
Yeah, if we made it an array list of objects, wouldn't we lose access to all of the methods that don't directly override methods in object?
Well, yes. If you made it an array list of objects, then you wouldn't be able to call paint on an object. You'd have to do a cast. And if I have time, I'll show you how to do that. In fact, you had to do that in the old days. When Java first came out, there were no generics. All you had were array lists. And it was just an array list of objects. Anything you got out, you had to know what it was so you could cast it to the right thing. Life is better now. So, okay, we got that. The constructor's the same. And look at the paint method. Now, the paint component method just has to iterate through each object in the shapes list and paint it. Right now it's not working. Let's see why not. It says shape doesn't have a paint method. Okay? And up here, okay, so let's see where else there are errors. Okay, there's where the mouse is pressed. We create a new oval and we assign it to this variable shape. S, rather, the variable S. Or we create a new rectangle, or we create a new line, and then when we're all done, we add S to that array. And it's basically telling you here, oval is not a shape. Cannot convert from oval to shape. All right, so something's missing from this program. Let's go below all this. I've got shape declared as an interface here. So what's missing? Why are we getting this mismatch? Why is it complaining that, hey, an oval is not a shape? What are you doing? What do we need to change about this so an oval is a kind of shape? Yeah?
Oval needs to implement shape.
He said oval needs to implement shape. I need to say here, implements shape. I need to say an oval is a kind of shape. And I need to do the same thing. Implement shape. Implement shape. Okay, very good. Most of our problems went away. There's still one remaining. It says right there that shape does not have a paint method. Yet, oval has a paint method, and rectangle has a paint method, and line has a paint method. So what's the problem? Yeah?
In interface, the interface for shape, you never define the paint method. So what it's looking at is if any shape can do paint. So oval, rectangle, and line will be able to do paint, but not every single shape.
Yeah. So bottom line is, what he was saying is, the interface needs to list all the methods that you can trust these classes that implement them, that implement the interface have in common. So all we care about is shape. So that's public is not shape, it's paint. We just need to see, this just says no one can claim to be a shape unless they have a paint method like that. Okay? Oval has a paint method like that, so it's fine, and so on. Now everything is good. And well, something's not good. There's still a red flag there. It's like it hasn't been updated. So anyway. That's good. Now let's pause to consider what what we have here. What we're building is called an object-oriented framework. So when yes, we're writing a program that allows us to draw different kinds of shapes. But we're also writing the program in such a way that it can grow in the future. It can change. So what's a way you can imagine changing this paint program, other than, there's functionality we want to add. In particular, the user needs to be able to control the size of these things. But besides that, what could you imagine adding to it? Yeah?
You could add a diamond class and it'll draw diamonds.
Right. Suppose we'd like to add a diamond class that draws as a diamond. Or we want to make a triangle class that lets you draw triangles. Now, the way it's structured right now, what will we have to change about the program in order to add a new shape to it?
Add another radio button.
Yeah, we would have to add a radio button to the interface. And we would have to create a triangle class or a diamond class. But as long as it implements the shape interface, we wouldn't have to change paint component at all. We wouldn't have to go back and change anything about it at all. So object-oriented frameworks use inheritance and interfaces to make it easy in the future for people to change the programs in certain ways. And Swing itself is a big, carefully designed object-oriented framework that, they can't imagine every kind of thing you'd ever want to put into an interface. So they make it so that by inheriting and overriding methods, you can, with a minimum of code, inherit a whole lot of power. I mean, just imagine if you had to, think about all the code that's being executed behind the scenes right now. Suppose you had to write that into every GUI you use. That wouldn't be fun at all. And this way, we have this program, and then when next year when Swing is souped up and made better, we automatically get that benefit of that because we're just we inherit all that. Okay, so there are two ways I could go right now, three ways I could go right now. One way, we have the question which was, what would happen if we called this an array list of objects instead of using interfaces? You know that every class is a kind of object. We could try that. Okay? What would happen? Another thing is we could worry about going to the next step, which is making it so that when you drag, when you click and drag, you actually set the dimension of the thing. So I'm going to do both. And the third thing I could do is stop early. That's what I'm going to do. I'm going to stop now. We will pick up with this next time and look at both these issues.
Minutes early?
So we're done.